Hello and welcome back. In this video, I will show you how to create a separate network namespace. When we create a separate namespace, we get our own set of network interfaces, network drivers, we get our own IP address namespace. You name a number, you can get it. It does not collide with the host system IP address namespace. So we get our own IP address namespace. We can configure any IP address that even belongs to host machine. These are two different namespaces, so they don't collide with each other. Similarly, we can get our own TCP port, UDP port, anything, whatever we want, because this is a separate namespace and it does not collide with whatever port that has been used in host machine. So let's go and create a new network namespace. The command for that is ipnetns command. NetNS stands for network namespace. So let's go and create a separate network namespace. And to list, we need to do list. It shows that we have created a new network namespace. And where to find this new network namespace? Let's do /var/run/netns. And here is where we'll see the new network namespace created. Let's create a virtual Ethernet interface under here. We need to first get into the network namespace. Just like we did a chroot into the new root file system, we need to enter the network namespace first. The command for that is ipnetns execute /bin/bash command with the new network namespace. And that's the command we are going to execute. So right now we are in the new network namespace. If I do ifconfig, it does not do anything because we are in the new network namespace. If I exit from the network namespace and then if I do config over here, it will list all the IP addresses on the interface in the host machine. Now if I go back into the bash shell of the new network namespace, nothing is there because I have not yet created any interfaces. So I'm going to create one new interface, a virtual Ethernet interface. It's a virtual interface, so it's not a real interface. And I'm going to bring that interface up. It has been created, we need to bring it up. Great. So if I do ifconfig now, we will see the virtual Ethernet interface that we created. We can even assign an IP address. We can do a socket connection on that IP address and the port. Everything will work fine. No issues. Because it's our own separate network namespace. If I exit from here, if I do ifconfig in the host machine, it will still show the host machine interfaces, host machine IP addresses, its loopback interface, everything. But if I go into the new network namespace, and if I do the ifconfig command, which will list all the interfaces, isn't this beautiful? That's what containers basically do. They create a separate network namespace, and then the processes running within the process namespace will be able to access only these interfaces. They do not talk through any other interfaces. In that way, their environment is contained, isolated, and then they use specific channel to talk to the external world. Now I will show you how to use another command, which is the ns enter command, namespace enter command, to get into the network namespace using the --net option, and then specify the namespace that we newly created. We actually created a new network namespace, and that exists under /var/run/netns as I showed you. It's over here. So I'm going to enter the new network namespace using this command. Instead of the IP, it says I need to use the root privileges. See, we still has got into the same network namespace, the new network namespace, and we see the virtual Ethernet interface that we created. It is the same network namespace, but we are using different commands to get the same result. Now let's combine all the three namespaces together using a single command. Using a single command, we can enter into the network namespace, we can unshare and then go into the process namespace, we can actually chroot and then go into the root file system. Let's do that. Right now, I am in the bash shell of the host machine. Beautiful. So we have created a separate file system namespace, which is the root of us, separate process namespace, and network namespace using a single command. If I do ps-ef, I'll see the processes running in my new namespace. If I do ifconfig, I'll show my interfaces. If I do ls, it will show me all the files in the new root of us. I can exit, go back to the host machine, do everything whatever I want, because it's a completely a different namespace, root file system namespace, process namespace, network namespace, all are different. And the moment I enter this one single command, I get a virtual isolated environment with its own file system namespace, process namespace. See, the numbering is unique. I get 1, I get 3. Then I can do ifconfig to check my new network namespace. Isn't this beautiful? This is what exactly containers do. Docker is nothing but a wrapper written on top of all these Linux kernel primitives. Linux provides all these functionalities through these various commands. All Docker does is hides all these gory details from the users. These are the primary secrets behind Docker containers. If you really wanted to know what is happening under the hood, then this is the way. I hope you really enjoyed learning from this video. If you wanted to learn more of these secrets and various interesting things about Linux and containers, let me know in the Udemy rating and feedback system. Thank you.